Hi guys, Mr. Hescox coming back to you. Chapter 9. There are only a few pieces of Chapter 9 that fit onto that PSSA science test in the spring. So what I generally do this time of year is I do this chapter very, very quickly. And it is literally, we talk about each section, you take your own notes on those review sheets, and then you take the take-home quiz. And there's no test on Chapter 9, so that should make some of you guys happy. The take-home quizzes do count like vocabulary quizzes when it's all said and done. Chapter 9 is all about organic compounds, and organic compounds all stem from carbon. Now, if you'll remember, carbon is a nonmetal, and carbon has 4 valence electrons. Organic compounds completely are based on carbon. And this organic compound has 4 bonding sites. Now, that's not only just carbon. Now, there's carbon, there's hydrogen, there's nitrogen, there's oxygen. There's all of these things that are used to mix together. But carbon, because of its 4 binding sites, can make 4 different bonds. It can make triple bonds, it can make double bonds. And those bonds can even become what we now know as rings or chains, and those rings or chains become very, very important. Here's a real common organic compound here in sugar. On the other hand, though, carbon dioxide, which is CO2, is not organic. Now, even though we breathe out carbon dioxide, it's not considered organic in carbon dioxide. Inorganic compounds are the ones that are not found in living things, where organic compounds tend to be your living things. These carbon molecules here, you see a single bond where you have one bond and 3 hydrogens on each one. There's a double bond there. This indicates 2 shared pairs. This is 1 shared pair of electrons. And in some cases, you get these triple bonds where you have 3 shared pairs. So carbon can form 4 different types of bonds. Oftentimes, you'll see them written in what they call a structural formula, where they don't draw in all of the electrons. These are the exact same molecules that you just saw before, but drawn in a structural molecule. I personally get more out of these type of molecules. I'm not a huge fan of these simplified ones. This is 2 carbons, 6 hydrogens. This is 2 carbons, 4 hydrogens, 2 carbons, 2 hydrogens. It's all about the shape and how the chain is in a carbon organic molecule to be what it does. You can have a branched chain that goes in different directions, like a tree branch, or you can have a straight chain. Most carbons form these chains, and then those chains bend back over themselves. So sometimes they actually can become rings, benzene, and some different types of rings that you may find. In this case, you have carbon 1, 2, you have 3, 4. There's 6 carbons here. And if I was going to show you where they actually are, so there would be a hydrogen here, hydrogen here, hydrogen here. Each one of these would have a hydrogen. I don't really like those simplified drawings. I prefer to show, especially 8th graders, where the hydrogens actually are. Now, these each have 6 carbons. These are what you'll have one of your vocabulary words are called isomers. Now, an isomer is the same number of carbons and the same number of hydrogens, but shaped differently. So here you have 1, 2, 3, 4, 5, 6. In this case, this is a branch chained hexane. By the way, 6 means hex. You have 6 carbons, like a hexagon. So in this case, your hydrogens are here, here, one down here, I literally don't care how you draw these hexanes, but I find it's easier to see where the carbons are. So you have a branch chain here and a straight chain there. Now, oftentimes you get rings. Now, these rings happen when a chain bends around and connects to itself. This real common one here is called benzene. It's used in a lot of cleaning products. It's also found in a lot of aromatic substances. It also gives vanilla its smell. So carbon molecules can be really, really large. Here's a huge one with 13 carbons. There's vanilla, which gets its smell from the benzene ring. There's plastic, which has benzenes and all kinds of different monomers in it. That brings us to the last part of this, which is isomers. Now, isomers have the same number of atoms, but are in different locations and they're built differently. So an isomer is just basically taking the same pieces of Legos and building something else. Butane has four. 1, 2, 3, 4. Isobutane still has 4 carbons, but now they're rearranged into a branch chain. And that changing is what allows us to make so many, literally infinite number of carbon compounds. So, ladies and gentlemen, let's make sure you get your review stuff done. There is a take-home quiz for 9.1 that needs to go with this, and then there's the fill-in like note-taking sheet in Google Classroom. And until next time, I'm Mr. Escox. Be good, be safe.